Hi, 103. Are we ready? We're going to talk about homeostasis and organ systems. So this is my lecture notes, and I'm about to embark with you. So I'm going to share the screen. Here we go. All right, homeostasis. Let's talk about this. Okay. Okay, so you can skim the books. Skim the book. It's a 200 level book, so skim it. Don't read it too in depth because we use parts of it. Okay, what is homeostasis? What does it mean to be homeostatic? It means that your body's internal, the pieces of your body, the internal components of your body must be maintained in a very narrow window. That's the scale that you're seeing there. So your blood glucose levels, if they go up a little bit, your body will do something probably with insulin or glucagon, some hormones to get it so that they go back into homeostasis. Same with water balance, same with all of the ions, electrolytes in your body, your body temperature, all of these things are kept in homeostasis. It turns out, even if it doesn't matter if you're considered cold-blooded or warm-blooded, it doesn't matter. We're going to keep you in homeostasis, okay? So it's a little bit different, right? Different organisms do different things, because if you're living at the bottom of an ocean, it's cold. And homeostasis for you is totally different than homeostasis for you and me, right? But that's okay. We all use homeostasis. If you don't, you get sick or die. Pretty much, if you're out of homeostasis for too long, you will get sick. And then longer than that, you will die. So there you have it. And then the other part of the chapter is talking about organ systems. Okay, so we will be looking at the organ systems of bodies, of organisms. It's so fun and what they do. And I bet you already know some of them. We're thinking with our which system? I'm drinking and digesting my food with which system? What do you think? So you already know some of the organ systems. We're just going to sort of get a general idea of those organ systems as we move into the next part of our class. So we're kind of at a milestone where we're changing into a different area. Do fish do homeostasis? Who does homeostasis? Right? Everybody does. So fish have to deal with living in water. Homeostasis about living in water. They're submersed in water all the time. So their homeostasis looks different for water than ours does. Same with ions. They're floating around. Our ions are not floating around. Well, unless that's true, they are if we drink them. Do birds do homeostasis? Yep, right? Totally different though, right? Because they have to deal with, they have really warm bodies and we don't. Our bodies are warm, but not as warm as birds, mostly. Birds are much warmer than ours. What about reptiles? How do they deal with homeostasis? All of us do. And we might want to put in the chat something about like how they might differ. Like how do reptiles regulate their body temperature versus me and you? It's different. Yeah. And if we leave it, what happens? Sick or die, sick or die. Oh, it's cheerful today. Okay. So we're going to talk about endo and ectotherms. Endothermy, ectothermy. So you and I are endotherms, excuse me, we're endotherms. We are warm-blooded, but we're going to call them endotherms. That means we regulate our body temperature. We have high caloric needs because we're going to have warm body temperatures, right? So we can live in environments that are pretty cold because we're going to regulate our body temperature. So you see organisms like us, animals that are like us, endotherms, all over the world, okay? Ectotherms are quote unquote cold-blooded and they don't regulate they still are in homeostasis and they still have to regulate their body temperature somewhat, but not as much. They're gonna rely on their environment more. And so they don't have to eat as much. Their metabolism is a lot slower. So ectothermy is cheap and in some ways better because you don't have to worry about where your next meal is all the time. Endothermy is expensive. So question for you to think about, why it seems like endothermy, trying to keep yourself warm all the time, is a really bad adaptation. Why is that not true? Okay, think about it. Why is that not true? Okay, and you want to write down several ectos and several endos. So you can think of ectotherms like reptiles, just write a whole bunch of reptiles down. Or you can write down fish. And then endotherms, you can think about you and me and those like us. Okay, we'll keep talking about it. This will not be the last talk about endothermy. We'll do it in lab this week too. Oh, I think that was it. Wait, hold on, let's make sure. It seems like endothermy is a bad idea. Why is this false? Organ systems. Okay, so organ systems are groups of organs that work together in a coordinated manner. We talked about homeostasis. There are 11 organ systems that we'll be going over. I have a nice little mnemonic for you, which is drummer's link. That's the first letter of all the organ systems that you have to worry about. So we will be looking at each of these organ systems. Now, do all organisms have all organ systems? That was a lot. Do all animals, like take a sponge, take a jellyfish. Do jellyfishes have hearts? No. So not all organisms, not all animals have these organ systems, okay? And that's fine. A lot of invertebrates, they either have them or they have like unique organ systems, which is cool. Like insects are amazing, but they don't do it like we do. So no problem. Do birds do homeostasis is a question, of course, right? Birds, not only do they do it, but they do it really well. And we'll see. A lot of ways birds have surpassed because of need, because they fly, they have surpassed us mammals in a lot of ways because of in terms of their organ systems, because they had to, right? Because they fly. So birds push things to the limit. We'll see that. What happens when we leave? Learn the mnemonic, drummer's link. Drummer's link. Okay, so you're going to watch the video to fill in your table. And I'm going to go over the organ systems with you right now. Just, you can fill in your table and you're going to watch the video before you get to class, okay? Because it goes over all the organ systems. But drummer's link, the first organ system, I think it'll be on here. Yeah. So D is for digestive, R is for respiratory, E is for excretory or urinary. Okay, so drummer's link is the U is for urinary, but we tend to say excretory. It's the same thing, yeah. Muscular, M is for muscular, E is for endocrine, R is for reproductive, S, so drummers, is for skeletal, link, so L is for lymphatic, I is for integument, oops, N is for nervous, and the last C, last but not least, is my favorite, is cardiovascular. Okay, let's go back up. And so you'll watch this video, and in the video, it will talk about major organs and major functions and miscellaneous examples that we will discuss, okay? So for example, for digestion, functions that you're probably going to be writing down would be things like digestion, that's to break down your was food, and absorption, that's to absorb the broken down food into your bloodstream. Major organs, I would put things like, I don't know, GI tract. So small intestine, large intestine, stomach, mouth, okay? Miscellaneous and each of these organ systems we're going to go into in depth. So you don't have to try to get everything at this moment. You just want to have some general pieces to fit in here. Miscellaneous examples, we didn't really discuss any special structures. Okay, so respiratory, what do you think of when you think of respiratory? Put down a couple of those organs, okay? Lungs or trachea or windpipe. Major functions, gas exchange. Yeah. See how I'm not putting in too many things. We want to keep it pretty basic. Excretory or urinary system is actually quite a system, my friends. So it looks like it's like, oh, no big deal. Cleans your blood, whatever. Ion or electrolyte balance, that's big. pH balance, water balance, and it cleans your blood. Wow. If you have blood, some animals don't have blood. So it cleans the fluid in your body. Let's say that. Organs, for mammals and birds and reptiles and amphibians, the organs you probably have heard of are like your kidneys and your ureter and your bladder. Those are good. Good. Muscular, yay, muscles. What do they do? Help you move. They do some other things too, but I think that's fine. Movement. Organs would be your muscles. You could also write tendons, but I think it's good. Tendons hold muscle to bone, but I think for 103, just the muscles themselves, it's great. Endocrine. So endocrine are hormones, and hormones, what they tend to do, you might have heard of thyroid hormone or growth hormone or follicle stimulating hormone, lots of hormones, estrogen, testosterone. So these, oxytocin, these hormones, what they do is they impact long-term homeostasis. So for example, your thyroid hormone, if you change how much thyroid hormone is being produced in your body today, you're not going to see much happening for probably 4 weeks. So long-term homeostasis is what I tend to think of with the endocrine system. Usually, not all hormones, but many hormones take much longer. They're on a longer time scale than just right now. Okay. Major organs, you can put in a couple glands if you want. Well, endocrine, you could say thyroid gland, pituitary gland, your pancreas. What else? Your heart, even. Believe it or not, your heart produces, I wouldn't put heart in there, but those glands are some good ideas for endocrine. Reproductive, so functions would be to reproduce for the next generation. There's probably some other functions, but for here that works. And major organs would be things like ovaries and testes and vagina and penis. Skeletal, okay? These are your bones. This is to help you with structure. Otherwise, you'd look like a jellyfish. And I'd look like a jellyfish if we didn't have it. So skeletal would be things like bones and ligaments. Bones are great though. That's your organs. And then the functions, support. They also help with a bunch of minerals. So they store minerals for us like calcium. But I think for us, I think it's good to say support, structure. Lymphatic, your lymphatic system is actually your major player of immunity. So when you're going to fight off, I don't want to say coronavirus, but when you're fighting off the flu or a bacterial infection, who does it? Your lymphatic system. The major organs would be things like your spleen and your thymus and lymph nodes. Sometimes people feel their neck and they're like, oh, it's swollen. They're feeling their lymph nodes. Yeah, because you have a lot in this area and a lot in the armpit area. Okay, so we've got the functions, your immunity, right? Big function. Integument is your skin and things attached to your skin like nails and hair. And what does it do? Protection. It does a lot of things, right? Helps you produce vitamin D and all kinds of other things. But your skin is here to protect you and also make it so that you don't lose too much water. So, but protection's great. Organs are your skin and your hair and your nails. Nervous system, oh my goodness. Every thought you have, think your nervous system, right? And also your nervous system also controls your body, controls your muscle. So every time you touch something hot, your nervous system, your brain says, I'm move this away, move my hand away. So I like to think of nervous system, it has too many functions to list. I say short-term homeostasis. That really includes thought too, thought and motivation and those sorts of things too. So short-term homeostasis, major organs would be your brain and your spinal cord and nerves. I think we're done. Oh no, cardiovascular, my favorite. Cardiovascular. Oh my goodness, what does cardiovascular do for you? It's like a highway, right? It transports gas, it transports nutrients, it transports hormones, it transports everything around your body. So important. Who's involved? your heart and your blood vessels are involved. Okay. And we'll talk more about all of these in future chapters. But this week, we're just sort of getting to know the main 11 organ systems. And that's what we'll be talking about the rest of the class. Whoop, whoop. Okay. I think we're done. Have a great day. Yay.